Hello, we're Emily Angad and Nafisa Azizi, and together we're Project Mist here to tell you about our project. Microplastics are defined as pieces of plastic that are less than 5 millimeters in diameter. There are around 261,000 tons of microplastic particles in the oceans, posing potential environmental and health issues. Because many microplastic filters are unaffordable, we aim to produce a compact and affordable faucet-attachable microplastic water filter. This idea was partly inspired by a scene in the CW series The Flash, where a scientist develops and tests a water filter to help a Kenyan village. We found that there had been some promise in the direction of filtering microplastics by utilizing static electricity and electric charges. Thus, we looked at especially triboelectric plastics. Plastics are triboelectric when they become electrically charged when separated from a contact material as a result of friction. We then found a research paper by environmentalist Mark Ward in which he detailed his method of utilizing these properties to design a large polymer-coated mesh sieve in order to sift out microplastics from beach sand. Our current mentor, Dr. McCrae Maxfield, showed us a newspaper article about the Interceptor, a plastic collection system utilizing a conveyor belt. Taking inspiration from the properties of triboelectric plastics, Ward's filtration device, and the design of the Interceptor, we created our own apparatus for filtering microplastics.
The apparatus box is made of wood. There are holes on the top and bottom of the main body for water to pass through. Centered between those two holes are a series of 3 sieves: the wool fabric, the polystyrene butadiene sieve, and the Cashmere fabric. Polystyrene butadiene is basically a natural black rubber plastic. We chose these specific materials because they have been found to be more triboelectric. These sheets are elevated and centered by 2 wood pieces with 3 slits. To the right of the sieves, there is a rod with an attached elliptical cam, also known as a thin oval-shaped wood piece, which spins when the motor outside of the box is powered. The rod is connected to the motor with the shaft coupling for more durability. When the rod spins, the cam spins in a manner that causes it to push the slitted wood piece, which is when the sieves and the other slitted wood piece also shifts. When the cam finishes its rotation, the whole sieve system returns to its original horizontal position. Found in previous experiments with this system, excluding the cashmere and wool fabrics, that 63% of the microplastics were removed, which we inferred was due to the sifting motion of the sieves, creating a greater triboelectric charge, separating the microplastics from the water flow. We predict that due to triboelectric and fine knit qualities of the cashmere and wool, there will be a greater transfer of charge, so a greater percentage of microplastic will stick onto the sieves and separate from the water. Our prototype is a larger version of the filter we hope to create. Thank you for listening to us, and we hope you like this presentation and our project.